Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. In the earlier sessions, we were talking about various components of time series. That is T, S, C and I. T stands for trend, S stands for seasonal variations, C stands for cyclical variations and I stands for irregular variations. Any data is the comprising of these 4 components. In continuation with the discussion of one of the component of time series, that is seasonal variations, we have discussed various methods. In continuance with that, in this session we are going to study about seasonal variations by the method of moving averages again and link relatives. We will go ahead to work out in computing the seasonal index by the method of moving averages, where original data is given in terms of quarters. For example, for the year 2001 has been divided into 4 quarters, each quarter consisting of 3 months. That is, for the first quarter, the price in rupees per 10 kilogram of the commodity is 75 rupees, and for the second quarter 60 rupees, for the third quarter 54 and fourth quarter 59. Like that, this data is given for 4 years from 2001 to 2004. You are asked to calculate seasonal index for this problem by the method of ratio to moving average. In the earlier session, we have also computed seasonal index by ratio to moving average, whereas the data is given in terms of months. So again, assuming multiplication model of time series, the trend moving average values are eliminated by expressing the given values yt as a percentage of trend values and are given in the last column of the following table. Now actually calculating seasonal index means calculating trend and eliminating trend is called calculating seasonal index, because any data is comprised of the 4 components as I was telling you, that is T, S, C, I. So C and I will be eliminated when you center the moving averages, therefore there remains only trend and seasonal. So to have S, it is easy to calculate trend and then divide those trend value, divide the original data by the trend values, then we will automatically get the seasonal index values. That is how seasonal index are calculated. Now look at this table, computation of moving average. Okay. So first of all, the years are written, and for each year the quarter is written here, first quarter, second quarter, third quarter and fourth quarter. So all the values given in the tabular column format in the question is written in this format, that is written vertically, like 75 of 60, 54, 59, like that. Similarly for the year 2002, 86, 65, 63, 80, like that it is written for the other years also. Then we have to calculate quarterly moving averages. So 4 quarterly moving totals are calculated. When you add the first 4 values, it has to be placed in between the second and third value. So in between there is no value corresponding to the year corresponding to the total. therefore it is written in between second and third value. So, this 248 is actually 75 plus 60 plus 54 plus 59, okay. And then it is centered. Similarly, this 259 is calculated leaving the first value. So, it is a total 259 is a total of 60 plus 54 plus 59 plus 86, okay. And likewise 273, 298 etc. are calculated, and then these values are added. So, for centering, because it is not representing any quarter or any year, therefore, it is centered as these two which is not having any corresponding year values, these two are added and written here, and it is written corresponding to the third quarter, okay. So, 507 is the total of 248 plus 259, and it is written in between 248 and 259. So, it is written here. Similarly, the values 259 and 273 are added and written like this. Then next, this 507 divided by 8 gives you 63.375. First of all, 4 values are added, so automatically it has to be divided by 4. When 2 more values are added, it automatically it will be divided by 8. Therefore, 507 by 8 gives you 63.375. Likewise, 523 divided by 8 gives you 65.375. Likewise, the values are calculated. Then ratio to moving average is the column 2 divided by column 5. Column 2 is the original data. So, corresponding to 63.375 which we have calculated is the moving average, and the corresponding value given in the question is 54. Therefore, it is column 2 divided by column 5 into 100, that is 54 divided by 63.375 into 100 is 85.2017. Likewise, the value 59 divided by 65.375 is 90.2485. Likewise, ratio to moving averages are calculated. Then let us see how this minus 9.375 comes from the calculations in the next slide. The seasonal indexes are obtained as averages, that is arithmetic mean, above are adjusted to a total of 400 by multiplying each of them by a constant factor. K is equal to 400 divided by sum of seasonal index. What is the sum of seasonal indexes? That is this is 398.865. Now, actually this tabular column is the trend eliminated values, because we have eliminated the trend values we have calculated from the original data. Actually, we have taken 54 is the original data. It is comprising of the 4 components. Since it is centered, already C and I goes off, therefore T and S only remains. So, this is original data Y value and this is trend value. So, Y divided by T gives you 85.2017. This is seasonal values. Now, when you see corresponding to 2001, there is no seasonal value for the first quarter and for the second quarter, whereas the seasonal value is available only from third quarter, then for fourth quarter. Similarly, 2002 first quarter, the values are written like this. Now, this has to be distributed in the tabular column in this format, that is trend eliminated values. For 2001, as discussed, there is no first quarter and second quarter value. The value starts from the third quarter, therefore 85.2071, and fourth quarter value is 90.2485. Likewise, you just write down all the values. Similarly, at the end for the year 2004, there is no value left out for third quarter and fourth quarter. That is, these values are not available because of centering the averages. Okay. Now, these three are added, 128.1192 plus 117.4551 plus 120.4819. These three values are added and written here, and then their arithmetic mean is taken, that is 366.0562 divided by 3 gives you 122.0187. So, 366.0562 by 3 is equal to 122.0187, and then we will see how it is adjusted. First of all, let us see how this row are calculated. Likewise, 276.4998 is obtained by adding these three values. Then 276.4998 divided by 3 gives you 92.16667. Likewise, these values, 4 values are calculated. Their total comes to be 398.865. Okay. Now, keeping this value in hand, let us see how we calculate the adjustment. That is, the adjustment goes like seasonal index obtained as averages above are adjusted to a total of 400. That is, by multiplying each of them by a constant factor. K is equal to, what is that constant factor? K is equal to 400 divided by sum of seasonal indexes. Sum of seasonal indexes is just now we have calculated 398.865. So, the adjustment factor, that is correction factor, is K is equal to 400 by 398.865, which is equal to 1.0028. Next, if we assume additive model of the time series, the trend eliminated values or short term fluctuations are obtained by subtracting the trend moving average values from the given time series values. That is, by the formula short term fluctuations is equal to original data minus moving average values. Minus moving average values is nothing but S plus I, and are given in the last column of the table, and these values are then used to obtain seasonal indexes as given in the last row of the following table. Let us see how this 1.008 is taken into account here. Adjusted seasonal index is equal to seasonal index into K, that is, this value is 122.0187, which you have calculated now, into 1.0028. 1.0028, that is equal to 122.3603. Likewise, here 92.1666 into 1.0028 is equal to 92.4246. Likewise, it is calculated. Now, if you see, the total comes to be equal to 399.985. It is almost equivalent to 400. That is, each should be nearly equal to 100, so that when you add all the 4 quarters, it should be equal to 400. So, 399.985 which is equal to approximated to 400. Now, the short term fluctuations. Short term fluctuations is calculated for the seasonal indexes, that is, for the year 2001, it is minus 9.375. How it is minus 9.375? If you see, that is original value minus moving average values, 54 minus 63.375, this value 54 minus 63.375 is equal to minus 9.375. Similarly, 59 minus 65.375 is minus 6.375. Again, when you see, according to centering the moving averages corresponding to the year 2001, first quarter and second quarter values are not available. Therefore, the short term fluctuations are available from third quarter to second quarter of 2004. Again, the third quarter and fourth quarter for 2004 is not available. Now, all these values starting from minus 9.375 to minus 6.750 is written in the tabular column in this format, isn't it? For 2001, first quarter and second quarter are not available. So, starting from minus 9.375, minus 6.375, and then we end up with minus 6.750. Okay. And the last third and fourth quarter values for the year 2004 is not available. Again, next you take the total of these three values, 18.875 plus 13.375 plus 17 gives you 49, and similarly minus 18.250 minus 33, and likewise the values are taken. Then take average. Since 49.25 is obtained by adding 3 values, 49.25 divided by 3 gives you 16.417. Similarly, minus 18.25 divided by 3 minus 6.083. Likewise, these values are calculated, and as usual just adjust it with the correction factor 1.008, that is 16.417 into 1.0028 is 16.511. Likewise, these values are also calculated, so that we obtain the adjustment total as equal to 0. That is, the fluctuation should be so minute that should be equal to 0. That is why it is called short term fluctuations. So, this kind of computation is called computation of seasonal index by ratio to moving averages. Just take the average total of the 4 values is 0.375. So, the correction factor is calculated in the next slide. K is equal to sum of seasonal indexes divided by 4. Sum of seasonal index is minus 0.375 divided by 4 is equal to minus 0.094. So, correction factor K is minus 0.094 and 16.417 into 0.094 is equal to 16.511. Similarly, minus 6.083 into 0.094 is equal to 5.989. The correction factor modulus has to be taken and it is calculated by 0.375 by 4. Likewise, these two values are calculated and the total is 0.001, it is nearer to 0. The fluctuations should be nearer to 0. The short term fluctuations should be nearer to 0, that is why it is called short term. After discussing the computation of seasonal index by ratio to trend method and ratio to moving average method, next we discuss computation of seasonal index by link relatives method. In the ratio to trend method, we calculated trend values using the method of least squares and the trend values are eliminated to obtain seasonal index. Next, by the method of moving averages are calculated and centered and it is written according to the corresponding year, so that the original data divided by trend values gives you seasonal index values, and that is how the seasonal index was calculated by ratio to moving average. Next, in the link relative method, among all the methods of measuring seasonal variation, link relative methods is the most difficult one. When this method is adopted, the following steps are taken to calculate seasonal variation indices. Calculate the link relatives of the seasonal figures. So, the original formula is current season's figure divided by previous season's figure into 100. These percentage are called link relatives, since they link each month or each quarter or other time period, that is each week or each fortnight, like that. Whatever the time period we are taking, it is relating or it is linking to the previous one, that is why it is called link relative method. We shall explain this with an example itself. Apply method of link relatives to the following data and calculate seasonal index. Quarterly process, the values are given. First quarter 2006, 6, 6.5, 7.8 and 8.7. Similarly, for the year 2007, 2008, 9 and 10, the values are given for 4 quarters. The solution goes like this: a computation of seasonal index by method of link relatives. First of all, for the year 2006, the first quarter value, because it is not having any previous value, therefore, first quarter value is just left as it is, and the values are written in this format, and for 108.3 corresponding to 108.3, that is a second quarter value. The previous one is 6.5. Just see, for the second quarter for the year 2006, the previous one is 6 and the current value is 6.5. So, for calculating link relatives, 6.5 divided by 6 into 100, isn't it? So, 108.3, 6.5 is current value and the previous value is 6 into 100. Similarly, for the third quarter, if you see, for the third quarter is 7.8 and the previous one is 6.5. So, 7.8 by 6.5 into 100 for the third quarter. Okay, and similarly, fourth quarter 8.7 by 7.8 into 100. Similarly, for the year 2007, the first quarter value is calculated using the fourth quarter of 2006. The fourth quarter of 2006 is the previous one. This one is the previous one and 5.4 is the current value. So, 5.4 by 8.7 into 100. Likewise, the values are calculated. Okay, and then just add for the arithmetic average 62.1 plus 93.2 plus 112.5 plus 77.6 is 345.4. Whatever be the total you are adding, when you want to take average, total of the values divided by total number of the values. Okay, so since you are adding 4 values and the total comes to be equal to 345.4, since you are adding 4 values, it has to be divided by 4, which is equal to 86.35. That is very important, because for the next second quarter we are adding 5 values starting from 108.3 plus 146.3 plus 95.6 plus 80.6 plus 110.6. You are adding 5 values and the total comes to be equal to 541.4. Since the total is the addition of 5 values, it has to be divided by 5 for the average, which is equal to 108.28. Likewise, 121.66 and 93.86 is calculated. Next, we are going to calculate chain relative. Chain relative, first value is always fixed as 100, that is very important. Always fix it as 100. For the next relative, just put the arrow mark like this, that is the current value, the previous one, into its average divided by 100. So, 100 into 108.28 by 100 is 108.28 itself. Then just put the arrow mark like this, that is previous quarter and the arithmetic average divided by 100. So, 108.28 into 121.66 by 100, which is 131.73. Similarly, the next value is 131.73 into 93.86 by 100. Then we have to corrected chain relative. This 1.675 is calculated using the calculation here. See, in the above table the correction factor has been calculated as follows. Chain relative of the first quarter on the basis of first quarter is 100. Chain relative of the first quarter is equal to 86.35 into 123.64, this value 86.35 into 123.64 by 100 is equal to 106.76. That is 86.35 is the arithmetic average which you have calculated, and 123.64 is the value we just now we have calculated as the last chain relative. So, according to the formula, the average into last chain relative divided by 100 gives you number. That number is equal to 106.76. Then the difference between these chain relatives is 106.76 minus 100 is equal to 6.76, and the difference per quarter is 6.76 divided by 4, which is equal to 1.675. So, 6.76 divided by 4, which is equal to 1.675. Now, these adjusted chain relatives are obtained by subtracting. For the second quarter is 1 into 1.6, because always the first quarter is 100. So, we have to adjust only from second quarter. So, for the second quarter it is adjusted by subtracting with 1 into 1.675, and for the third quarter it is adjusted with 2 into 1.675, and for the third quarter 3 into 1.675 from the chain relatives of second, third and fourth quarters respectively. See, 108.28 is the value which is calculated minus the correction factor 1.675. How this 1.675 is calculated? The first arithmetic average link relative into last chain relative. So, 86.35 into 123.64 divided by 100, that comes to be equal to 106.76, that is subtracted with 100, 6.76, that is divided by 4, which gives you 1.675. So, likewise this is 131.73 minus 2 into 1.675, which is 128.38, and this is 123.64 minus 3 times 1.675 is 118.675. Then seasonal index is 100. So, for the second quarter 106.605 divided by 113.4. How the 113.4 has come? Seasonal variation have been calculated like this. Take the total divided by 4, and this is the average of seasonal indexes. Average of seasonal index is 113.4. So, seasonal variation index is corrected chain relative into 100 divided by 113.4. Okay. This 113.4 is the total seasonal index average of chain relatives. Then each one is divided, corrected chain relative by average of chain relatives into 100 is 94. So, these are the left out seasonal index values. In this session, we were talking about methods to calculate seasonal index. We have also worked out a problem in computing seasonal index by the method of moving averages, and link relative method was studied. Also, a problem is worked out in computing the seasonal index by link relative method. Based on the discussion in this session, the following question may be posed. Compute the seasonal index by the link relatives method for the adjoining data relating to average quarterly price, that is rupees per kilogram of a commodity for the 5 years are given starting from 1996 to 2000. So, the quarter values are given starting from 30, 26, 22, 36 are the 4 quarter values for 1996, and we have to compute seasonal index by link relative method. Thank you.